Good afternoon, everyone. We're already past almost the lunch break hours, so I'll try to be quick in my presentation and avoid beating around the bush. So I'll probably stick to my notes. As Lorena just mentioned, we have contributed to the environmental platform in the Rotate project, a module devoted to risk assessment. And we have designed it in order to provide clear and objective quantitative information about the potential impact of an open pit operation on the surrounding ecosystems and human communities. As a diagnostic system, the risk assessment module identifies the most relevant exposure pathways for nearby receptors and offers a numerical estimate of the risk associated with each one of them. This information is very easy to interpret and to transmit. It offers a common language and a level ground for discussion, and thus it facilitates communication with and among all the interested stakeholders, neighbors in affected communities, local, regional, and national authorities, environmental groups, and others. And hopefully this agnostic, objective, science-based assessment can help build trust among all the parties involved and, very importantly, appease concerns regarding the potential damage to the environment and the health of individuals when this supposed damage is not supported by hard facts. The risk assessment module is structured into two levels of increasing complexity, called Tier 1 and Tier 2. And as opposed to the Tier 2 assessment, the Tier 1 submodule is much simpler, but also much less site-specific. And the idea behind this structure is that a Tier 2 assessment should only be applied when the results obtained in a Tier 1 indicate the need for a more detailed analysis. So our risk assessment model includes both off-site and on-site exposure scenarios, on-site within the mining operation itself, mainly related to occupational conditions, and off-site scenarios in the surroundings of the mine, in which potential receptors, ecological or human, may be exposed following the migration of contaminants from their source areas. The first level of the assessment, the Tier 1, it's a generic and highly simplified analysis that provides a screening, a preliminary classification of the potential risk posed by the operation, and it's based on four main factors: the toxicity of the contaminants, the hazards, the quantity of those substances present on site, which dictates the contamination potential, the sensitivity of the receptors, either within the mine boundaries or in the surroundings, and the directness or immediacy of the mechanisms that may bring those substances into contact with the potential receptors. By assigning scores to each of these variables, a single estimate of risk is calculated, and then it is classified into four levels: low, moderate, high, and very high. In the first version of the environmental platform, we have included 5 groups of contaminants. This catalog can be easily expanded to accommodate new contaminants. As it is now, we have included petroleum products, basically diesel, fuel and lubricating oils, crystalline silica, acrylamide used in flocculants, diisocyanates used in polyurethane foams, and dichloromethane as a solvent and degreasing agent. The model is very straightforward to use because most of the required information is already preloaded in the system. So in practice, the user only needs to provide information about which substances from the defined catalog are handled at the operation. The model already contains the toxicity data for those substances, the quantities of those substances involved in the operation, the presence of nearby populations or protected areas, and the distance between these receptors and the mining operation. And that's it. As you can see, both the effort required and the level of technical expertise needed to operate this tool are minimal. It is also very important to stress that a high or very high classification does not imply that a damage will occur. Rather, what it means is that a more refined and site-specific assessment is needed, and that would be the tier 2 stage of the model. So when that happens, when the tier 1 assessment indicates the need for higher quality or for more reliable information to rule out the possibility of an unacceptable risk, then and only then we move on to the second tier of this assessment. And at this stage, the quality of the information provided by the model is much higher, but so are the costs and the technical expertise needed to run the model. As a matter of fact, running a tier 2 assessment demands a site-specific characterization of the operation, including sampling and laboratory analysis to quantify parameters such as hydraulic conductivity in the saturated zone or the vadose zone, frequency of exposure of receptors to potentially contaminated media, substance-specific toxic profiles for each contaminant, and many other factors. But the main advantage of a tier 2, despite its complexity, is that the model output now it's a quantitative estimate of risk, a probability, which can be directly compared with predefined acceptability criteria. In this synthetic artificial example that I'm showing you in the slide, we're evaluating the risk associated with exposure to drinking water, groundwater, contaminated with dichloromethane, which has been accidentally released at the mine. You can see the plume of dichloromethane migrating from the source, and above this image, you have a table specifically related to risk for human health, which in this case are all of them, or are all acceptable for all the receptors considered in this model, if we accept the acceptability limits that are used in other industrial sectors. What is more important, if there is any aspect for which the uncertainty of these results remains so high that we cannot categorically rule out a potential unacceptable risk, then the model allows to identify exactly where the problem lies and to implement targeted mitigation measures to address it. So in conclusion, the risk assessment module is a powerful diagnostic tool to identify potential impacts and therefore to design preventive actions specifically targeted to those impacts. In the same line, it helps design monitoring strategies aimed at controlling those potential risks. And since any stakeholder can use this tool and the results are traceable and are reproducible, in other words, since all actors are playing with the same deck of cards, communication becomes much easier and debate becomes much more objective. Now, a last advantage of the this module is that if the results of the risk assessment suggest that the situation is unacceptable, then quantitative and specific goals can be set to revert that situation. And if, on the other hand, the results of the risk assessment fall well within what is acceptable, well, then permitting should be fairly straightforward, and surrounding communities should enjoy the peace of mind to know that the nearby quarry will cause no damage to their health or their environment. So thank you very much for your attention.